Tell you about the graph of G prime. So be careful, we gotta say G prime of X is decreasing at X equals -1 because G double prime of X is less than 0. This actually tells us something about the original graph G of X. Okay? So, right, it tells us that the previous one is decreasing, but it also describes the concavity of the original graph G of X. So here we get a negative value, right, for the second derivative. So that tells us that the concavity of the original function is concave what? Concave down. Okay? So that would mean that my tangent line approximations would be what? Overestimates or underestimates? Over, right? Because if I'm concave down, where are my tangent lines? On top of it, right? Ooh. This is deep, right? Oh my God, this is beautiful. And if we relate it to physics, right? This is the velocity, and the rate of change of the velocity is called the acceleration, right? So the second derivative is the acceleration, right? So if the velocity is negative and the acceleration is negative, what can you tell me about the object? Is the object speeding up or slowing down?
Slowing down.
Slowing down?
Well,
Let's see, come up here.
wait, come
up here.
Do you mean accelerating in a certain direction then?
Well, I mean, if the acceleration is negative, the negative is just
Then
telling
it's
you the direction.
accelerating it's getting faster in a different direction.
Accelerating, but in a different.
It's in a different direction? The velocity was negative, and this one's negative, and I think that's the same direction, don't you think?
Yeah.
So come up here, Monse, so we can do an experiment for the class.
That's left. I'm done.
It will be done on me, so do not worry. You will just be performing. You will be the external force. You will be the acceleration. Okay? So I'm the velocity, and the velocity is negative, so that means I'm traveling to the what?
Left.
To the left, but this is going to be my left, okay?
Okay.
So I'm going this way, right? At some particular velocity. That's what this says. -5/2. But then there's some external force, right? Some acceleration that is providing that force in the same direction, right? So she's the acceleration. So I'm moving this way and she's going to push me, and you tell me what happened to me. Like push me. No, like push me.
Like hard.
Just
Push hard.
So what happened to my velocity?
You got faster.
I accelerated, so what happened to me? I what? Did I speed up or did I slow down?
Sped up.
I sped up, right? Because the external force that was applied to me was in the same direction that I was already moving, right? What if they're in opposite directions? So I'm moving this way and she's applying the acceleration this way. Go. Now what's happening to my... What's happening?
Monse, go harder.
I'm slowing down, right?
Slowing down.
Okay, good job. Thank you, Monse. Excellent. So when we start talking about all that, we'll hopefully come back to that and make a connection. But when both derivatives are the same sign, right, then you know that the object is actually speeding up because they're both going in the same direction. If they're opposite signs, it means one force is being applied one way and the other is going the other way, so they're slowing each other down. One of them stopping each other. So for example, if you're in a car and there's an 18-wheeler in front of you, and you're accelerating, but they're not, and you crash, right? Okay? Like some seniors yesterday. What happened to the speed of the car?
Completely stopped.
What happens to the speed of the car? Did it speed up or slow down? Slow down because they had forces in opposite directions.
The car was really quiet.
So luckily that student did not get injured severely. So you know, pray for her, keep her in your prayers, and make wise decisions when you're driving. Yeah, be careful, okay? Don't go to senior skip day, okay?
Next year.
Yes.
Yeah. Don't drink and drive. Don't text and drive, okay?
Next year.
Be very careful. You have pictures?
Next year. Next year.
Oh, you have the burn picture. Wow. How about the car picture?
The car was here.
Wait, what
Put on the
happened?
group chat?
Yeah, what's up?
Oh, I got out of the group
Oh,
chat.
no,
Everybody
no,
has
no,
it.
she put it on Snap.
She put it on Snap. The whole front of her car was damaged.
What happened?
Like damage.
Who was
She crashed with an 18-wheeler.
Yeah, like Mr. Paulson has a challenge